Question 5. The diagram shows a square-based pyramid placed on top of a cube relative to the coordinate axes. Okay, so let's just highlight our axes, shall we? So there's our x-axis along here, and in orange I'll show the y-axis, and in green we'll do the z-axis. Oh, look at that! That was quite good. Not bad. Not bad at all. Okay, so that's our three planes. So when we give a coordinate, we would give a coordinate, give the x, we would give the y, and we would give the z. Okay, so all that is how far from the x, y, and z is the point. Okay, so how far along into the page and then up the page is it? Okay. So what do we know? We know the height of the pyramid is half the height of the cube. Okay. A is a point 600. Now this is a cube, and this is 600. I know, and I'll mark this up, and again I'll go for a different colour. That'll look nice. We'll just do pink. Pink. I know that this length is 6. Okay, because this point A is 6 along from here to here. So the cube is 6 by 6, isn't it? It's a cube. Okay, so it's 6 by 6 by 6. Okay, the height is 6, the width is 6, and the breadth is 6. That's a really powerful point they've just told us there. Okay, that's 6. Let's go back to my blue pen. So I now no longer really need to think about this information. Apart from, the height of the pyramid is half the height of the cube. So if the cube is 6, then the pyramid is 3. Okay. Point C is directly above the centre, right in the middle. Yeah, okay, I can kind of see that from the drawing. I'm going to write down the coordinates of B and C. Okay. I'm just going to write it on the side here actually, just so we can keep the diagram in sight. So I'm going to put B, I'm going to put C, I'm going to say X, Y, and Z. So that's me set up for the answer, okay? So, point B, where is that in the x-plane? So this is the x-plane in purple. How far along is it? Well, it's 0 along, isn't it? Okay, we're not moving that way at all. Okay. How far is it in the y direction? Well, it's going to be 6, isn't it? Because we're travelling all the way to the other end of the cube. And how far is it up the way? Well, it's got to be 6, because it's at the top of the cube. So nice and easy, 0, 6, 6. I almost don't even think this really qualifies as math. I kind of feel this is something that primary kids could do. You're just really measuring out, and where these points are. It's a bit like battleships, actually. There's really not much to this at all. I suppose understanding the language of pyramids and cubes, understanding what a cube is, knowing that that's 6 by 6 by 6. That's probably the only mathematical part about this. But yeah, this shouldn't be too tough if you just take your time and label your diagram. So 066, that would be worth 1 mark. There's not really a lot of wiggle room with these. You get it right, you get it wrong, unfortunately. And the other one was point C. So where's point C? Point C is right in the middle. Okay, so a little bit, trickier for point C. First thing is it's the very top of the pyramid, isn't it? So in terms of Z, it's the height of the cube plus the height of the pyramid, isn't it? So I know that's 9 right away. Okay, but then let's think about X and Y. So where is this in relation to the cube? It's right above the middle point, isn't it? Okay, right above the middle. So if we were to look at this in plan, okay. So let's say that's still my x-axis, and that's still my y-axis. The point would be right in the middle. Okay, that point C would be right in the middle. So this diagram that I've drawn is kind of like we're looking from up here. Okay, with x, and there's my x. All right. So it's right in the middle, and I know that this length is 6 and this length is 6. How far over and up have I had to go? I've gone over 3, and I've gone up 3. 3. Simple as that. Okay, there really is not much to those questions at all. Tick. So when you see a big massive shape with some coordinates, rub your hands together. Okay, 2 easy marks. All right, barely maths, Okay, and again, you might be looking at these thinking this looks very similar to the last paper I just did. They are very similar to the previous 2 papers I've just uploaded. All right, so again, if you're struggling with some of the concepts, practice the questions because you will get into the routine of how they ask them. Some trickier ones you might struggle with if you just have that shallower, understanding, but there'll be a lot of marks you'll get just purely by understanding the type of questions you're going to get asked. Okay. Question 6, again, favorite of the SQA. So the diagram below shows a straight line joining points A and B. Straight line, that's the key word. Okay. Find the equation of the line and give it in the simplest form. Okay, so equation of a straight line. For me, the equation of a straight line is y is equal to mx plus c. Okay, so m is the gradient. And c is the y-intercept. So what that means is, I'll just go over here. Every line's got a gradient, okay? And the gradient is the ratio of the height over the length, okay? So there's the gradient. So this line I've just drawn here has got a steeper gradient than this line here. This line I've just drawn here has got a negative gradient. It's going down the way. Okay, so gradient's just your hills. Is it it's like a hill. Is it steep? Is it not? Okay, and c is when it crosses the y-axis. Okay, or when x is equal to 0. Okay, so it's the intercept where it crosses that. Okay, so there's the intercept there. Okay, so that's a little introduction to the equation of a straight line. So we can see here we're definitely going to have a negative gradient, and it's crossing the y-axis up here. Okay, now y is equal to 6, and this is obviously 0, so I'd be guessing it's going to be about 4 for the y-intercept, but we can work that out. Okay. So how do we work out the gradient? That's the first thing we always do. Well, our equation is y2 minus y1 divided by x2 minus x1. It doesn't matter if this is 0.1 or this is 0.1, it doesn't matter as long as we're consistent. Okay. What does that actually mean, that equation? Well, if we've got a line, all we're really doing is working out the height and the length. There's the height, there's the length, and dividing them. So height over length. That's literally it. Okay. This is a very fancy mathematical way of saying difference in height over difference in length. Okay. So I'll call A 0.1 and we'll call B 0.2. Okay. So y2 is minus 2. Take away y1, which is minus, so take away 6. x2 is 3. And I'm going to take away minus 1, which is x1. I'm just going to double check that. y2 minus y1, x2, take away x1. 3x2, yeah, good stuff. So minus 2, take away 6, minus 8, and 3 plus 1 is going to give us 4. Okay, 2 negatives make a positive. So it's going to give us minus 2. Minus 8 divided by 4, minus 2. So that makes sense to me. It's going in the right direction. Doesn't look too steep, okay? If we think about a graph like this, that is m equals 1. If we say that when x is 1, y is 1. When x is 2, y is 2. Okay? When x is 3, y is 3. Okay? That's your standard m is equal to 1. Okay? And I'm looking at that and thinking that's probably not, it's definitely steeper than a 45 degree. That'd be your m equals 1. So m equals minus 1 would be maybe not quite like that actually. Let's see if I can draw it in better. I'll use the shapes. Let's see. I think that kind of looks like a minus 1. So it's steeper than minus 1. Definitely. This one is steeper. So -2, yep, twice as steep. I could live with that. That makes sense to me. The point I'm trying to make is if you got, -0.01 or something quite small, I'll be thinking, well, it's not a shallow. It's not shallower than 1. It should be a bigger number than 1. Okay. So -2, that's really good. The next thing we need to work out is our c value. Okay. So we know that y is equal to mx plus c, and we know that n is -2. So let's just sub in. Let's pick a point. Let's take point B. Okay, and we'll just sub that in to this equation. So y is -2, and x is equal to 3. I'll just put it in a wee bracket, plus c. So -2 is equal to -6 plus c. So therefore c is going to have to be 4, isn't it? Now I know c is going to be equal to 4, but if you weren't sure, well, let's try and rearrange this to make c the subject. Okay, so I've got a -6 on this side, and I want to get rid of it, so I'm going to have to add 6 to both sides. So it's going to be -2 plus 6 is equal to -6 plus 6 c. So on this side, that's going to cancel out, and on this side, -2 plus 6 gives us 4. Okay, so 4 is equal to c. And let's just rewrite that. Y is equal to -2x plus 4. And like I said, 4 makes sense, doesn't it? Because it's cutting just below, well, not just below, but below the 6. Okay. Have we answered the question in its simplest form? I think that looks pretty simple. It doesn't get much simpler than that. So, what does the marking scheme say? Red pen. So you're going to get a mark for finding the gradient. Okay, so you get a mark for your -2. You're going to get a mark when you substitute the gradient back in, and then your final equation. So your final equation gets a mark. So it's basically a mark for gradient, intercept, and final equation.